So I think we started what we were going over at the end of yesterday.
Okay.
Like if it's 0.
Oh,
Okay.
0 over 0? Right.
Yeah.
Right.
Okay. So I have the limit of t squared
Okay.
minus 3t plus 2 all over t squared minus 4. And then t is approaching 2.
So the denominator goes to 0, and the numerator goes to 4 minus 6 plus 2, which is also 0.
Mm-hmm.
So the secret on these, first thing, is to try to factor. There are other types of problems like this where the solution is not necessarily factoring. But if you see a quadratic, you can almost bet that it needs to be factored.
Mm-hmm.
What's the top factorand?
So t minus 2 and minus 1.
The bottom?
T minus 4 and then plus 4.
T minus
I mean 2,
2,
sorry.
t plus 2.
Yeah.
And one clue is that one of the factors in the numerator is going to be in the denominator. You can bet.
Mm-hmm.
So if you don't find a t minus 2 or a t minus 1, you've made a mistake almost certainly.
Okay.
Okay. Now what can you do?
Get rid of t minus 2 on both, and then substitute.
Let's try resubstituting again.
Yeah. So it would be 1 over 4.
Yeah, that's the limit.
Okay. Alright, I have 2 plus x in parentheses, and then to the third, minus 8, all over x, and then x is approaching 0.
Okay, top's 0, the bottom is 0.
Mm-hmm.
Now one thing we could do is what we did yesterday on a problem like this, which is expand the top and simplify. And you'll notice one thing that's going to happen is the 8's are going to disappear. Because the very first term, or eventually that becomes 8 when you cube it. And you're going to have 8 minus 8, and every other term is going to have an x in it, which you're going to be able to factor out. But that's a lot of work.
Mm-hmm.
Notice that I can look at the numerator as the difference of perfect cubes. Okay, so let's go down here and talk about how the difference of cubes factors, because this is going to be an easier way to do it, I think. Yeah, it will be, for sure. What's a cubed minus b cubed equal? First term is always the same sign and linear. Notice a squared minus b squared. First term is the same sign and always linear. The next term is a plus b. Well, oh man. What's the next term here? I think what happens is I must rest my hand on the drawing tablet. Because every now and then it just kind of is all I got to be is anywhere near the thing. It makes a line. So I'll try to be careful. They have taught you, no doubt, difference of perfect cubes and sum of perfect cubes.
Mm-hmm.
Well, the difference of perfect cubes is relatively easy to remember, especially if you remember this pattern where the first factor is linear and the same sign as what you started with.
Okay.
The next factor, opposite sign, AB, and always plus B squared. And just for good measure, let's go over the sum of perfect cubes. There is no sum of perfect squares, but odd exponents do have a factor. And this first term is linear, same sign. Next term is quadratic, opposite sign.
Okay.
So notice the pattern. If you can memorize that, you can almost memorize all three because they're very, very similar. You just have to notice the differences. But
Okay.
the most important thing to me is this first term is always linear and the same sign as this. That's why I really don't like it when I say what's the difference of squares and somebody tells me a plus b times a minus b, which is a true statement, but it messes with the method that you're going to use to memorize all three of them.
Okay.
Now, that being the case, how do I factor this numerator? Notice the first term is the cube root of a minus the cube root of b. What's the cube root of a?
So what would a be then? X?
Well, 2 plus x. It's whatever's being cubed.
Okay.
In other words, that's the secret when you use this, is you have to figure out what a is and what a cubed is. Well, a cubed is clearly this whole thing. So a is 2 plus x. And the rest of it is a squared not sure this is going to be easier now that I think about it, plus 8, or not 8, but 2, because b is 2.
Right.
A is 2 plus x plus 4. Makes it a little bit easier.
Okay.
I think. Boy, you know, it doesn't make it that much easier than just expanding that in the first place. I thought it was going to save us some steps. But in order to do it this way, we have to figure out what the difference of perfect cubes is, and then we're still going to have to expand it. So that being the case, let's just go back and expand it, and you'll see what I'm talking about. What's 2 plus x squared?
Wait.
Let's square it first, and then we'll multiply it by another 2 plus x.
Oh, okay. So, 4 plus x squared.
No, 4 plus 4x plus x squared. In other words, you have to multiply 2 plus x times 2 plus x. You have a middle term of 4x.
Oh, okay.
So I haven't changed anything.
Okay.
And that's the key whenever you're doing math, is to always make sure that at every step of the way you haven't changed anything. Because all I did was I took 2 plus x squared times 2 plus x.
Right.
8. Now let's expand this.
Okay, so you just distribute it, right?
Well, right. If you've been taught FOIL, FOIL does not work when you have a trinomial by a binomial.
Right.
So you basically have to do every term by every term.
Okay.
That should be really easy for you because I call it ET. And given that that's your initials, you should be able to remember ET pretty easily. And what
Okay.
ET means, I'm going to take that, multiply it by that, and then I'm going to multiply it by that, and then I'm going to take that term, multiply it by that, multiply it by that. In other words, every term is going to be multiplied by every other term, and you're going to add them all together.
Okay.
So let's do that. And always use a methodology here that is consistent. Don't jump around.
Okay.
In other words, take that 4 and multiply it by both terms.
Okay, so 8 and 4x.
Now take the 4x and multiply it by both terms.
Okay, so 8x and 8x squared, or 4x squared.
And now take this third term and multiply it by both terms.
So 2x squared and then x to the third.
And we still have this minus 8. And the whole thing is still being divided by that. Okay? So that was the difficulty, was expanding it, was doing both of those multiplications. Now, which is always going to happen, is this number is going to cancel out with that number. And every other term has an x in it.
Okay.
So let me get rid of everything that I've written here that we don't need, although I'm not disappointed that we went over it, because that is stuff you're going to need to know. Difference of squares and difference of cubes and how to apply it to certain kinds of functions.
Okay.
So what are we left with here? Divide top and bottom by x and tell me what's left.
Okay,
You don't have to combine the top. Let's just divide everything by x, and what do we got?
So 3x.
4x?
What do you start with?
Very first term. Divide that by x. I'm going to divide every one of these terms by x.
So you would divide 8 by x?
Right?
Okay.
So those are our first two terms.
Oh, wait, do you...
Keep going. We'll simplify. We'll combine them, but there's no need to combine them at this point. We're just dividing every single term by x.
Right, but how did you get 4 from dividing it by x?
4x divided by x is 4.
Oh, okay.
8x divided by x is 8.
Okay. So then that would just be 4x.
Keep going.
And then 2x. And then x squared.
Okay. Now what is the limit of that expression as x goes to 0?
Limit, so 12, just 12.
Exactly.
Oh, okay.
Okay. Got another one?
Yeah. Let's see.
I'm going to have to be a little careful today not to run over. I have got back to back to back to back to back today, so I don't have much wiggle room in between.
Okay. Let's see. Sine x over 2x squared minus x. And then x is approaching 0.
Okay. Let's first of all do this. In other words, factor where you can. Hold on. I didn't quite do it right. As I checked it to make sure it was correct, and it wasn't. Now, what is this? This is the same as the one they told you memorize that.
Mm-hmm.
Correct?
Yes.
No difference between those two. Well,
Okay.
what's the limit of that as x goes to 0?
Wasn't it 1?
Correct? And what's the limit of this as x goes to 0?
So that would be 1 over -1.
So we have 1 times -1.
Mm-hmm.
So our limit is -1.
Okay, that makes sense.
Okay.
Um,
Good, they're getting harder, more challenging.
yeah. Let's see. Okay, so I have, assume that limit f of x equals 7 and limit g of x equals -3. And then the problem is limit f of x plus g of x, and then that's all in parentheses.
Hold on. Let's see, I got a fix. Maybe works. We'll try.
Mm-hmm.
So you want to do, hold on, now I got to push some of these things. So you want to do f of x plus g of x
Yeah, and then all of that is in parentheses.
as x goes to
B.
And do we know what x is going to give us these limits on f of x? Is that with x going to b?
Yeah, both of those are x going to be.
Okay. Well, obviously, what is that as f goes, or as x goes to b? What is that limit?
7?
Mm-hmm. And what's the
Okay.
other one as x goes to b?
-3.
So our answer is 4. In other
Oh,
words, the limit of the sum is the same as the sum of the limit.
okay. That makes sense.
Real quick, I'm going to try one other program here to see if I can cure my problem here. Naturally, it's no longer there because I never thought I would need it again, so I took it off my tile. See if this program doesn't work a little bit better.
Okay.
So far, it doesn't even show up. Oh, here we go. Almost seems to. Question is, I've never used this program, so I'm not sure how to advance the page, but it may solve some of our problems. Well, I'll try it.
Okay.
With it. What's the next problem?
Okay. Let's see. Sine squared x over x, and then x is approaching 0.
Okay. Factor the numerator.
So,
What's sine squared of x mean?
there's 2 signs.
It means sine of x times sine of x.
Oh, okay.
That's exactly what it means. And incidentally, it's not the same as this. This means you square x first and then take the sine of it.
Okay.
When the 2 is between the n and the x, like that, then it merely means you're squaring the sine of x.
Okay.
So after I've, I can't see my cursor unfortunately with this thing. So, ooh. Second. Wow. Guess I got to click on that with my mouse. Well, where's the x go?
Yeah.
Oh gosh, what am I going to do? I may have to go out and buy a new bamboo. Gosh. So again, I haven't changed it, but I have converted it into something where we know what the sine of x over x does.
Okay.
Do again?
Is that just the same, so it'll just be 1?
And what does this do as x goes to 0?
So that'd just be the sine of 0, which is also 1?
No, sine of 0 is 0.
Oh, okay.
So this limit is 0.
Oh, okay.
When you have a number times 0, it's 0 regardless of what the number is.
So if you just plug that into the original equation, wouldn't you get 0 over 0 and then it'd just be 0 too?
No, because 0 over 0 is not always 0.
Okay.
0 over 0 is indeterminate. We don't know what 0 over 0 is. In other words, the reason that is 1, notice that the sine of 0 is 0. I have 0 over 0 with the sine of x over x. But that limit is actually equal to 1. 0 over 0 is called indeterminate because it can be 0, it can be infinity, it can be any number.
Okay.
It's indeterminate until you do more things.
Okay.
And if I did plug it in directly, I would have gotten 0 over 0 and wouldn't have known what it was really until I separate it out and I know that that one is 1 and this one is 0. So now I have 1 times 0.
Okay.
All these buttons down here, and they don't tell you what any of them are. It's not actually curing my problem anyway. So let me go back to OneNote. All right, what else?
Okay. Let's see. So 1 over 2 plus x.
Hold on.
Minus 1/2 all over x, and then x is approaching 0 for the limit.
Notice that we get 0 over 0. Okay, this is one of the stranger ones. You're not going to solve this by factoring. But you can solve it by subtracting that numerator, by go ahead and performing the subtraction. In other words, how do I do 1 over 2 plus x minus 1 over 2? What's the trick?
I'm not sure.
Find a common denominator.
Oh, okay.
So the way I like to do these is like this. Okay? In other words, I know that I'm going to need a common denominator here that's the same as here, and I have to figure out what this numerator is going to be, what this numerator is going to be, and then combine them.
Okay.
What's the common denominator going to be?
2 plus x.
2 plus x times 2.
Okay.
In other words, the definition of least common denominator is it has to be divisible by both terms. Well, this is. If I just put 2 plus x, well, that's divisible by 2 plus x, but it's not divisible by 2.
Mm-hmm.
But the product always is. So
Okay.
one way you can automatically get it, it won't always be a least common denominator, but just multiply the two numbers and you'll have a common denominator.
Okay.
It's not always the least, but you don't really need it to be the least to come up with the answer.
Right.
Now what's the numerator here have to be?
Oh,
Remember,
okay.
I cannot change the fraction. I still have to end up with 1 over 2 plus x.
Mm-hmm.
What number would cause that? The way you get it is you take this denominator, divide it into your common denominator. Whatever you get, you multiply by this numerator.
So, would that be 2x?
Just 2.
Just 2, okay.
Now look at this fraction and compare it with this fraction. Not different, right? The 2's would cancel and I would end up with 1 over 2 plus x.
Right.
Okay? That's important. Always do that step along the way. It'll cut way down on mistakes. Because where you have a problem that has 7 or 8 steps in it, you get to a wrong answer and figuring out which one is very difficult. So the best way to handle that is to check along the way. Now, what kind of numerator do I need here so that this fraction will be the same as 1/2? Again, here's the format. Take your 2, divide it into the common denominator, take your answer and multiply it by this numerator, which is 1.
Okay. Would that just be 1?
Well, is that the same fraction?
No. That would be 2.
Is that the same fraction?
2. Oh, it's 1/2.
Divide 2 times 2 plus x by 2. What do you get?
Just 2 plus x.
That's it.
Okay.
Now, is that the same fraction?
Yes.
Yeah, because the 2 plus x's would cancel and I would be left with 1/2. Now, very, very important step. Put that in parentheses.
Okay.
If you don't, you will get the wrong answer.
Okay.
And this is one of the rare cases where we have to add parentheses where it doesn't look really obvious that we're going to need them. Well, here's my denominator. What's my numerator? Now remove the parentheses and simplify.
Just x.
Plus or minus?
Negative.
Negative. That's why I put the parentheses around it.
Okay.
If I left the parentheses out, then it's far easier to make the mistake of not distributing this negative sign to the x. But this negative sign needs to be distributed to both of those terms.
Okay.
Okay. So now I have this as my new numerator. This is still my denominator. And just to make it more simple to think about, let's put a 1 under that.
Okay.
Because what's the next step going to be? How do you divide fractions by other fractions? How would you divide 1/4 by 1/3?
Could you get rid of the 1s?
No, you got to flip the bottom and multiply.
Okay.
None of us have ever divided a fraction by a fraction. We've always done it the easy way, which is to flip the bottom and multiply. So this becomes 3/4. It's really easy if you turn it into a multiplication problem.
Okay.
A lot of division problems are really multiplication problems. You just have to know that we're going to turn this into a multiplication problem. So here's what we have. We have minus x over 2 times 2 plus x. I'm flipping this and multiplying. See what's going to happen here? Now, as x goes to 0, we don't get 0 over 0. What do we get? We got rid of the x's there and there.
Yeah. So that'd be
minus 1 in the top.
Yeah.
What happens to the bottom when x goes to 0?
That'd just be 4.
Right. So there's
okay.
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 So this is another technique for handling when you have 0 over 0, and factoring really isn't a possibility.
Okay.
At no point did I really factor anything here. I just did the algebra. And if anything, calculus is difficult algebra. Whether you're doing limits or differential calculus, you better be up on your algebra skills. Being able to subtract or add fractions, especially when they're complicated fractions like these. Okay? It's 3:31. I gotta run. Sorry.
No, you're fine.
Glad my tablet lasted as long as it did. So I'll talk to you tomorrow.
Okay, thank you.
All right, bye-bye.
Bye.